Hello, welcome you all for the next session of the welding. In this I am going to discuss about the TIG welding, that is a tungsten inert gas welding, and MIG welding, that is a metal inert gas welding. Okay, here these two types of the welding, what happens that one, how that welding is to be performed, that I am going to discuss. First I will take that is tungsten inert gas TIG welding. The TIG welding is similar to that of the arc welding. In the arc welding, how working is taking place, that we will discuss, so that the similar working is there for the TIG welding also. In the arc welding, the one pole of the circuit forms a workpiece, the another pole of the circuit, electric circuit, forms a electrode. And in the arc welding, the electrode whatever we are going to use, that is covered with a flux coating, and that flux coating is required in order to form a shielding gas. The shielding gas is required when the molten metal forms, molten metal forms between the two metal pieces and melting of the electrode itself, that when it is in a molten state, that readily combines with atmospheric contaminants, that forms a metal oxides. The metal oxide whatever forming is there, that is the rust, and that is reduces the strength of the welded joint. In order to have that one, the molten metal full, before the solidifying, it should be protected from the outside environment by shielding gas. That shielding gas is provided in the arc welding by using the flux coating on the electrode, and that whatever the flux coating is there, it will be forms a slag, and slag whatever is there, that will be later removed by the chipping, and that is the another additional work requires in the arc welding. For that reason, the another method is provided. There the gas shield whatever is there, from the outside gas cylinder only, the shielding gas is supplied, so that the gas shield will be formed. There is no slag formation, and it also protects the molten metal from the environment. Okay, that is the main, that is aim of this tungsten inert gas welding. The tungsten inert gas consists similar to that of the arc welding, that is a welding power source. One pole is connected to workpiece, another pole is connected to the electrode. This is a tungsten electrode, and here the electrode whatever is there, the electrode holder whatever is there, in that the inside the paths are provided in order to supply the gas, so that the whatever the gas is there, inert gas, and that will be supplied from the cylinder, and that gas is supplied to this electrode holder, and there the passage is provided, not flow of the gas, and that will comes to the whatever the welding spot. At that spot, there the protection it will be taking place, and outside the insulating is provided, and this gas passages will be there. Okay, that how the similar to that arc welding. Okay, then by using the inert gas supply separately, that we are going to weld that one, and tungsten whatever the electrode is used, and the inert gas is supplied that one. That's why it's called as a tungsten inert gas welding. And here the working whatever is there, that what I have explained. Okay, that is first we have to put on, that is a power supply to this circuit, and the gas supply we have to put on. Then the momentarily we have to touch the workpiece, and later we have to separate it for the at a distance of 1.5 to 3 mm distance, so that the arc will sustain for the shorter duration. Okay, for the melting of the base metal as well as for melting of the electrode or a filler material. Then the molten fuel will be formed at the joint, and if it is allowed to solidify it, the joint will be formed, welded joint will be formed, that one. And for the certain time period, about the few seconds, the electrode is momentarily withdrawn for a somewhat larger distance, then arc will be impinges, and the arc whatever is there, that will not continues. Okay, then the whatever the gas is there, it seals that one, whatever the molten fuel is there. Like this, the welding will be taking place in the tungsten inert gas welding. Then continuation of this one, the explanation how we can take. In this operation, the workpiece is to be joined or cleaned to remove the dirt, grease and the other oxides chemically or mechanically to obtain the sound weld. Okay, its cleaning is carried out first. Then welding current and enhanced gas supply are turned on. Then an arc is struck by touching the tip of the tungsten electrode with the workpiece, and instantaneously the electrode is separated from the workpiece by a small distance of 1.5 to 3 mm, such that arc still remains between the electrode and the workpiece. The high intensity of arc melts the workpiece, forming a small molten metal full. Filler metal in the form of rod is added manually to the front end of the weld full. Okay, here the filler metal is added manually, it is added. The deposited filler metal fills the and bonds the joint to form a single piece of metal. Okay, here the deposited metal whatever is there and the molten full together forms a single piece of a metal. The arc is extinguished by widening the gap between the workpiece and the electrode. Then shielding gas is allowed to impinge on the solidifying weld full for a few seconds even after the arc is extinguished. After the arc extinguishing, okay, the few seconds it should be held there at that position only. Okay, now to have that shielding. This will avoid the atmospheric contamination of the solidifying metal, thereby increasing the strength of the weld. That is about that TIG welding. Then what are the advantages of this TIG welding? Suitable for thin metals. This is used for the thin metals. Clear visibility of the arc provides the operator to have the greater control over the weld. In the arc welding, there is no clear visibility because of the formation of the slag whatever is there, and that whatever the inert gas is there, that is not provides a clear visibility, and here there will be clear visibility is there. Then strong and high quality joints are obtained. Strong and high quality joints are obtained from this welding. No flux is used. The flux coating is not used on the electrode. Hence no slag formation. This results in a clean weld joint. Okay, those are the advantages associated with the TIG welding. The disadvantage: TIG is most difficult process compared to all other welding processes. It is the most difficult process, that one, because manually we have to add that is whatever the electrode is filler material is there, and also the gas and electricity we need to control it, and that's why it's a difficult task, that one. Okay. For that reason the skilled operator is required. Process is slower. Okay, the process is slower compared to that arc welding process, and not suitable for the thick metals. TIG welding is suitable for the thin metals only, that's why it is not suitable for the thick metals. Continuation with that one, the another type of the welding, there is a metal inert gas welding. In the metal inert gas welding, compared to the TIG welding, it is a more convenient and it is a most automated type of the welding. Working is similar, but how the automation will be taking place, that we will see here from this one. Okay, that I told you that one. Here again one pole of the electric circuit forms a workpiece, and another pole will be the electrode. Torch is there, and here whatever the gas is used, the metal inert gas is used, that one, and in the separate tank, and that is supplied through a control valve to the welding torch. And wire whatever is the filler rod material wire is there, that is also it is supplied automatically. Okay, that is the drive is provided in order to supply that filler rod. And here the initially the cleaning of the whatever the workpiece is there, that is to be carried out for welding purpose. Then the whatever this electric circuit is there, that is put on, and the gas supply is started. Then also the whatever the supply of the electrode is also started. Then here the instantaneously that the electrode is touched to the workpiece, then separated for a distance of 1.5 to 3 mm. Then Here arc is still remains between the electrode and the metal workpiece, then that whatever is there due to that arc between these two sufficient for the melting of the base metal as well as the filler rod what we are going to supply. And later the whatever the gas is there, that will be impinges over that molten metal foil, and that provides a sealing gas to that protects from the atmospheric contamination. Okay, that is initially it is continuous welding will be carried out, and later it will be separated for a few seconds, and that extinguishing of the arc will be taking place, and the supply of the gas will be there. That provides the sealing of the gas. Thereby, that is clean welding it also provides, and most automated it is, and not manually automated. The welding also can be carried out by using the metal inert gas, and this also we can explain here. In this operation, the workpieces to be joined are cleaned, remove the dust, grease and the other oxides chemically or manually to obtain the sound weld. The tip of the electrode is also cleaned with wire brush. The electrode is also cleaned. The control switch provided in the welding torch is switched on to initiate the electric power, sealing gas and wire, electrode feed, all the started, that one for the feeding. An arc is struck by touching the tip of the electrode with the workpiece, and instantaneously electrode is separated from the workpiece by a small distance of 1.5 to 3 mm, such that arc still remains between the electrode and the workpiece. The high intensity of the arc melts the workpiece metal, forming a small molten foil. At the same time, the tip of the electrode also melts and combines with the molten metal of the workpiece, thereby filling the gap between the two workpieces. The deposited metal upon solidification bonds the joint to form single piece of metal. Okay. Then sealing gas is allowed to impinge on the solidifying weld full for a few seconds, even after the arc is extinguished. This will avoid the atmospheric contamination of the solidifying metal and thereby increasing the strength of the joint. It is very similar to that TIG welding, but the difference is that one, the more automation is there in this one, and also the thick metal sheets also we can weld by using this one, and most convenient welding compared to that TIG welding. Then we'll go for the advantages and disadvantages of this MIG welding. MIG welding is fast and economical. Compared to that TIG, it will be fast and economical. The electrode and inert gas are automatically fed. Here the electrode as well as the inert gas are automatically fed here. Okay. This reduces the burden on the operator and also helps him to concentrate on the arc. Okay, to concentrate on the welding process only, that can happen and helps him. Weld deposition rate is high due to the continuous wire feed. The continuous wire feed will be there. Okay, that is automatic feeding. Due to that, a higher deposition rate of that wire, that whatever the filler material is there. No flux is used, hence no slag formation. This results in a clean weld, similar to that of the TIG. Thick and thin metals can be welded. Both we can weld here. That is used for only thin metal welding, and this is thick and thin metals can be welded. Process can be automated. Here, without involvement of the operator, by automated way also we can carry out the welding by using this MIG welding or metal inert gas welding. Disadvantages: equipment is costlier. As automation is there, due to that the equipment is costlier. Dross and porosity are the most prevalent quality problems in this process. Dross and porosity means here the inside, the some in the welded joints, the some cracks or some bubbles may be present, that porosity gaps may be present, that one, and that is the most prevalent quality problems in this process. However, extensive edge preparation can eliminate this effect. The edge of whatever the metal pieces are to be joined, if that preparation is carried out initially, then that whatever the problem of dross and porosity is there, that can be eliminated. These are the advantages and disadvantages concerned to the MIG welding. And we in this session we have discussed the TIG welding and the MIG welding working and their advantages and disadvantages, and for which we are going to apply this one. Thanks for watching. Subscribe, comment and share my videos and continue for watching. Thanks once.